Let's take a problem on arithmetic progression. Let A1, A2, A3 up to n terms, that is An, be in AP. If A3 plus A7 plus A11 plus A15 is equals to 72, then find the sum of its first 17 terms. So we are given that A1, A2, A3 up to the n terms, that is An, are in AP. Let's assume that this arithmetic progression has a common difference of D. Then the nth term, that is An, or in such any general term An, can be written as A1, that is the first term, plus n minus 1, that is the number of terms minus 1, into D, where D is the common difference. So the second term can be written as A1 plus 2 minus 1 into D, which is equal to A1 plus D. A3 can be written as A1 plus 2D, and so on. So now we take the sum, that is A3 plus A7 plus A11 plus A15 is equals to 72. We write this equation in terms of the first term and the common difference D. So we have A3 plus A7 plus A11 plus A15 is equals to 72, which implies A3 can be written as A1 plus 2D, A7 can be written as A1 plus 6D, A11 can be written as A1 plus 10D, and A15 can be written as A1 plus 14D, which is equals to 72. Now solving this, we get 4A1 plus 32D is equals to 72. That is A1 plus 8D is equals to 18. Now we name this as equation number 1. So we are required to find the sum of the first 17 terms of the AP. Now we know that the sum of the first 17 terms of an AP can be given as S equals to n by 2 into 2a plus n minus 1 into D, where a is the first term, n is the number of terms, and D is the common difference. So in this question we have n is equals to 17, a is equals to a1, and D equals to the common difference. So we can rewrite this as 17 by 2 into 2a1 plus 17 minus 1, which is equal to 16, to D. Now we can divide this numerator by 2. So we have 17 into a1 plus 8d. Now we have from equation 1 the value of a1 plus 8d to be equal to 18. So the sum of the n terms, that is n is equals to 17, comes out to be 17 into 18, which is equal to 306. So the sum of the first 17 terms of this AP comes out to be 306.